So welcome back for lunch, everyone. My name's Allison Okamura. I'm a professor here in mechanical engineering with a courtesy in computer science and one of the co-organizers of this conference. So to kick off our afternoon program, I have the pleasure of introducing our afternoon keynote speaker. And the title of this talk is Robots Among Us, Shaping Human-Centered Robotics for a Shared Future of Education, Work, and Care from Maja Mataric. Maja is the Chan Soon-Shiong Distinguished Professor of Computer Science, Neuroscience, and Pediatrics at the University of Southern California, where she also directs the USC Robotics and Autonomous Systems Center and co-directs USC Robotics Research Lab. She earned her PhD from MIT in 1994 after receiving MS and BS from MIT and the University of Kansas, respectively. She is a member of the National Academy of Arts and Sciences and the National Academy of Engineering. She's received numerous awards, including the Presidential Award for Excellence in Science, Mathematics, and Engineering Mentoring, the Anita Borg Institute Women of Vision Award, and the NSF Career Award. She's also a fellow of the AAAS, IEEE, AAAI, and one more acronym, ACM. Her research focuses on socially assistive robotics, developing technologies to help individuals with autism, dementia, stroke recovery, and more. Maja is also deeply involved in K-12 STEM education through the USC Viterbi K-12 STEM Center and developed a number of educational programs and resources. And in addition to this academic leadership, she co-founded Embodied, Inc., which in 2016 launched Moxie, an in-home robot for child development, and she's a principal scientist at Google DeepMind. I have to say personally that she's also been an incredible champion of women in robotics, and I can't say enough about how much I've personally appreciated her mentorship over the years. So thanks for the privilege of letting me introduce Maja, and thank you all, and please welcome Maja Mataric. Thank you.
You know, the introductions just get longer and longer as you get older, so, you know, we could be here for hours. But it is wonderful to be here. There's so many wonderful colleagues and friends that are here and also joined remotely. This is an amazing meeting. It's also wonderful to be speaking as a keynote along with my advisor, who spoke this morning, Rod Brooks. And so let's see if we agree. Let's see if I can be as spicy. We will see. That's my goal. So in case you lost track about what's happening, AI. So I have actually been giving talks with that title of Robots Among Us for quite a while. But now, this has a whole different meaning in the context that we're in. So let's see, what does it mean and what might we do about it? So when I was a graduate student some eons ago, Marvin Minsky was still around the AI lab at MIT. And one of the things he would like to say is, don't try to define things that you don't understand. And I think here we are, you know, AI, it's here, is it here? We still don't fully agree on what intelligence is. And I don't want to define it now, but I do want to give us context because it'll relate profoundly to robotics and it'll hopefully relate to what I will talk about. So I just want to remind us that human intelligence evolved in a context of the body and the environment. So it is embodied and situated, and that is truly fundamental. And it's fundamental about, as we'll see, AGI as well. Really, what an intelligence does is a symphony of the physical, cognitive, and social emotional. And that part we have not touched on yet, but we need to, so I'll touch on that. And to remind you, if you look at evolutionary theory, what we know is that the complexity of the human brain, the evolution of that complexity was driven by the complexities of our social structures. So as we evolved, we created ever more complex social structures and organizations, which drove the complexity of our reasoning and so on. So that social bit is incredibly important. It is not a veneer that you add later. Like Wendy mentioned earlier today, the social part is not something you add at the end. The human part is not something you add after you have your robots working. No, it's fundamental, it's developmental. It's something that we need from the beginning. So just a little bit of talk about AGI because it's, you know, it's the talk of the town, especially this town, but it's the talk of every town. So what I'm going to argue, and hopefully what roboticists in general will argue, that intelligence, especially general intelligence, it requires embodiment. So you really cannot have a general intelligence that is language only. And we're starting to see that more and more, and I don't think we need to argue it, but if you'd like to, I'm happy to argue it, just not during my talk time. So we do need that embodiment. And in fact, the human-robot interaction presents a domain where we can get not just data, but a much more profound understanding of not only how we need to build robots, but what makes us humans tick the way we tick. And so this interaction between humans and machines, just like the interactions between and among humans, is a social construct. It's something social that we do and that we're wired to do. And so I'm going to keep coming back to that because I think right now, we know that, oh yes, intelligence is language, it's cognitive. Everyone agrees on that. And then some people, especially people in this room, hopefully agree that it's also embodied, it's physical. But the social bit has still been overlooked, which is a huge omission, massive blind spot. So I'm going to bring you in so that you are not suffering from the blind spot. And just so that we're on the same page, why do we care about human intelligence in the era of eventual AGI? Well, because we're creating it for this society and this planet and this humanity. So I think that's important to keep in mind. So how do we build machines that people will accept? Sorry to tell you, whatever we build, however amazing it is, will be rejected by some people. And in some cases, many, many people. People have very different opinions, in-groups, feelings, contexts, lived experiences. So there is no great uniform answer. And that's problematic, especially for companies that are building products. And it calls for us to better understand ourselves and our social relationships and therefore our relationships with machines. So studies have shown for decades now, at least about a quarter of a century of human-robot interaction research. Whew, not new. Also agents, I just have to say, I can't help myself, but everyone says, agents, this is new. I have a bag from the Autonomous Agents Conference from 1999. I still have the bag. So it's not new. I'm just going to show the bag to everyone. So studies in HRI have shown consistently that we as humans will very readily give assumptions and kind of credit for agency, goals, intent, emotion to machines and therefore to robots. We will feel relatedness, we will feel empathy, we will be helpful, but also we will have cognitive dissonance, we will think it's creepy, we will abuse robots. We do all of these things. You could choose to prefer one or the other, but we do both, and we do both a lot. And why is that? It's because robots are like us, but not quite like us. So depending on what your background is, what your context is, you may see a robot as related and you're comfortable with it and you feel really good about it, or you may feel like it's other. So it's really about in-group, out-group. And that's what we do to one another, and that's what we do to machines as well. So how do we, again, create machines that people will accept? Well, my very biased take, because also for a quarter of a century I've been working in this field, is that there are vast needs and opportunities. And I think when you give people machines that are actually improving their quality of life, usually in an area that's an area of pain, like something, doesn't have to be physical pain, but something that's really hard. If you solve someone's problem, they will find motivation to accept the technology. And there are a lot of real problems to work on. And it's not clear that people are necessarily mostly working on real problems. I'll say that as a spicy take. So we should work more on real problems, like real needs people have. And yes, assistive. And while we do that, we need to have more balance. And this slide, this little picture, I've had that for at least 15 years. And it's a problem, and it's ever worse. This need to balance automation and augmentation. And I was so happy this morning that the very introduction of this entire event was put in the context of human augmentation. So, we need humans, so we don't want to just make us all obsolete. And so the goal for the kinds of things that I'm going to talk about is to create these accessible and personalized technologies that are really, they come from delightful interactions with machines, and yet those delightful interactions result in helping us in some context, whether it's therapy, education, training, whatever it may be. So that's the context. And then, of course, that's the context for this field of socially assisted robotics, which I'm firmly attached to. And it's just really important to look at the evidence over many decades now a great many technologies have been developed that use advanced perception to monitor what we do as humans, to understand us better. And there are a lot of technologies also that will help us with various actions, some physical, mostly non-physical. So like, coaching, training, therapy, etc. This all exists, and it is insufficient. And I know some people will argue with me, but there is not an app for that. There's not an app that will fix your depression. There's not an app that will fix your anxiety. There's not an app that will fix your post-stroke recovery. There just isn't. And there's a reason for that. Because what we need is something to give us motivation to do the really hard things, and then also something, usually the same thing, that helps us have the grit to get through failure and to keep trying the really hard stuff. And what is that? Well, that's usually some other human. But it can't always be, and we can't always have our wonderful, helpful humans 24/7, and sadly these days ever less so. And so it's very interesting to see how technology can mediate this and help us have the motivation and the grit without having some adverse effects that also might happen, and we'll talk about that as well. So that's what the goal of this field is, and it was an article in the New Yorker back in 2009, boy do I feel old, but it's still a good image. Robots that care, I like that handle, I've been using it for years. Why do they have to be robots? This is an era of agents. I am happy that agents have finally been made possible. They've been around for a while, but they were in academia. Now we have real agents backed by mostly language models, increasingly foundation models. This is great, but we do have a large literature to show that in human agent interactions, when that agent is physically embodied, people enjoy it more, they learn better, they retain the information better, they delight in it more. All the positive measures and outcomes are better. And so I got so tired of answering the question of why does it have to be a robot, that I encouraged collaborators to do a meta review. And so as of 2019 anyway, the data are very strongly in favor of physically embodied interactions. They don't have to be physical as in touch. They just need to be in this physical world. And I'm just going to tell you right now, stay with me, because at the end of the talk, I'm going to show you some really recent results that are really compelling on this very topic. So stay with me. Take a nap now, but at the end, it's going to be good. No naps. All right. So I'm going to talk about various bits of work from my amazing students over many years. I want to talk about physicality and social interaction, how they're fundamentally intertwined in humans anyway. So we wanted to help babies learn in case they had developmental delays, and for many developmental delays, including, for example, autism, you don't have a diagnosis early enough, but you might have a risk through siblings, and then you might want to intervene early. How do you intervene? How do you get a baby to move its body in a particular desirable way that you want? Well, you can't do it. You can't tell babies what to do. Turns out you can't tell anyone what to do, but that's a whole other thing. But you think you can. But with babies, you know you can't. So how do we get a baby to kick its left leg with a particular force and strength? Because they need to do that because rehab. Okay, so I was so inspired by this work in my own lab. But it was just a beautiful notion that even babies are already fundamentally social beings. And so when they are around other social creatures, like humans shaped and ideally baby-sized, they're motivated to imitate. That's the mirror neurons, right? So it turns out if we take a baby-sized, sort of baby-shaped robot, the closest thing available was a Now. I know it's not baby-shaped, but okay, it's close enough. If you put it across a baby and you get it to move around in ways that we predictably know are what will be surprising, and there are models for this, like E.T. and Baldy have a salience model, the baby will look predictably where the surprising stimulus is, and then will imitate. And their imitation is not inhibited because they're, very young. You're all also, like if I go like this, your body is actually ready to imitate me, but you are, fortunately, all of you currently are, inhibiting that. Some people have a neural deficit that actually disinhibits, and they do imitate. It's like echolalia physically. So we are wired to be physically embodied. We understand each other by socially mirroring the physical behavior of others. Literally, the way you understand my social intent is by physically mirroring my body in your brain right now. That's exciting, right? So the physicality and the social are deeply connected. I trust this will be relevant. So we did this with babies. We got babies, like basically puppeteering babies. And the thing that's really key here is you cannot do this with a screen. You can show many things to babies on screens, and their cortices will light up, and they will not imitate. So that's interesting. It's developmental, right? Because if, we didn't evolve for screens. So this was just a beautiful demonstration, plus it helped babies. I like it. My student Nathan Denler, on the job market, just mentioning, did some beautiful work on understanding how people project expectations on robots. So this has been mentioned earlier today. Rod mentioned it in particular about robots promising things based on their embodiment. I don't need to remind you about the part of embodiment he mentioned. Yeah, everyone remembers? You should. It was very memorable. So my student Nathan actually looked at the IEEE database of robots and just did a large study to figure out, when you see a robot like this, what are your expectations? And it turns out we're so incredibly biased. We're biased about zoomorphic robots. We're biased about robot size. We're biased about robot form. It's really informative, because then when you're designing a robot, you might want to understand these inherent biases before you move on. And they're not always intuitive. So we also did some more work, again, this is Nathan and others, looking at what influences users' perception of gender with robots. And this is really interesting. So first of all, you ascribe gender to robots. You can't help yourself. You're human, therefore you ascribe gender. Is it good or bad? Doesn't matter. You can't help it. So you're doing it, whether you like it or not. But how can we influence this as designers? And it's really interesting, because you could dress a robot any which way, and you can tell someone anything. But it's the voice of the robot that ultimately biases you the most. But then we make the voice gender neutral and kind of technical, and then the stereotypes start to emerge. So it's really interesting how we can titrate these biases. And biases are just cognitive shortcuts. We all have them. But it's interesting in design. So we like this idea that the voice makes all the difference. And so we were looking at creating robots that would help university students do mindfulness exercises, because we could all use some mindfulness. And I'll tell you later why it's important that it's a robot. But we wanted to see different voices, and in fact voices on different embodiments, from a robot to a speaker to just a chatbot. And it turns out that if I gave you lots of different voices for mindfulness to choose from, you would all want something different. You would prefer a human voice, even if it doesn't match the body, like we had human voices with the little bunny-like robot, and I thought that would be cognitively dissonant, but it wasn't. So people always prefer a human voice. That's getting much better. So automated speech is getting much, much better, but we haven't crossed that point yet. People are still like that if you talk to humans, you're much less likely to be depressed than if you're just texting. Our brains are wired for talking to others, no surprise. But it turns out if you give people the ability to adjust the robot voice, just even a little bit, then they love it almost as much as synthetic voices. But the adjustments that they make are all over the place. So there is no answer, back to my original point, there's no answer to the question, what is the best robot voice? There's no answer for that. All of you will not form uniform clusters, and we're relatively uniform culturally here as things go. So it really has to do with personalization and autonomy. Giving the user a little freedom to adjust things makes the user feel much better. That's confirmation bias. And then also just making it, having them have the ability to choose in this giant space of preferences. And this issue of personalization is one that I'm going to come back to again and again. The social interaction and the personalization are the fundamentally powerful things that we need to work on with AI. So we're really interested in social constructs. You got that already. So one of the things that we were interested in is, your likelihood of getting along with someone and being more productive with them is very high if your personalities align. What is personality? It's very highly dimensional. It's difficult to measure. It's difficult to replicate those results. But the big five is a good measure of personality. While I'm at that, Myers-Briggs is not. It is a cult. But it's true, look it up. But the big five, at the top 5 dimensions of personality, relatively stable. So we wanted to imbue robots with personality, and we went for the extroversion, introversion spectrum. And we found a very strong effect. This was ages ago. This was like 20 years ago we did this. So the robot is, relatively clunky, but it's a humanoid. Hello. Humanoids from like 20 years ago. The idea was simply an extrovert will generally talk more per unit time Gee, you wonder what I am. So more words per unit time, slightly higher pitched, even normalized for gender, shorter interpersonal distance, and more gesture. Again, we didn't do this with any Italians, but it is culture normalized. More gesture. And then the opposite for people who are very introverted, and then it's, of course, a spectrum. And so we endowed robots with this extroversion, introversion personalities. And we found that when we personality matched them with users who were doing really boring tasks and rehab tasks like shelving books forever, remember that motivation bit from the beginning? They performed the task much longer, significantly longer, when they were with a personality matched robot than when they were not. And when you asked them which one they preferred, the extroverts in general would be like, I like that one, and that was the extroverted one. The introverts were not as explicit about what they preferred, and yet their performance was significantly longer with the introverted robot, which tells us multiple things. First, personality is a powerful predictor and important to design, and two, it tells us that self-report is flawed, but we've known that. So this is the era of AI that talks, and therefore it has personality, or at least we think it might have personality, or maybe we want to shape it to have personality. So in some recent work that we did in the last 2 years at Google DeepMind, we actually wanted to, one, unearth whether there's a latent personality in different models. And then, whether there is or isn't, could you shape it? And I think now, it's been about 1.5 years. This paper has a lot of hits on arXiv. It's very cited, so we're grateful. It's pretty well understood that you can shape robot personality or agent personality very effectively. So you can create agents that have the personality you desire, and that is the future. This is where we're going. You can also create personalities that are very undesirable, like the dark triad. And so it's interesting to see, where this goes, how safe is it, but it is very powerful and it is very real, and it's here. And I think in general, people are not going to want transactional interactions from technology. We already want agentic personality, persona-driven interactions. So ages ago, we did some work on backstories for personas for robots. We looked at it for exercise robots. We looked at it for robots that were teaching first graders about food choices. There's really nothing more boring for first graders than being told about don't eat white bread and all of that. Super boring. It's a great task. You always want tasks that are actually challenging, like teaching a kid about healthy food, and then measuring what they pick when no one's watching or they think no one's watching. Not asking them, oh yes, of course, I will take the brown bread. No, watch what they actually do. So functional evaluation. And we did that with first graders and adolescents. We gave them backstories, and it was really interesting because in every case, humans across the ages are very willing to suspend disbelief and believe whatever. Oh, this robot is from planet Vega, and it doesn't like gravity, and that's why it can't really do jumping jacks or burpees or whatever. Oh, but when it says that it understands that you're feeling bad because it used to be overweight, boom, that's where the suspension of disbelief ends. Why? Is it because we fundamentally know that robots can't really get larger or smaller? No, it's because that, in this study with overweight teenagers, that's a very visceral, really personal thing. And this is what gets back to this lived experience in-group, out-group thing. For them, that is their group, and the robot doesn't fit into that group. It can't really relate. And this is really important as we build these agents and we build backstories to understand what matters in a given context for a given user and to personalize over time. And so we did this, again, recently at DeepMind. We did this in the context of health agents. We wanted to see if we can actually simulate personas that are very similar to real patients in the real world. And we did this with demographically grounded data, and it's under conference review, which is why I don't have but it's on arXiv, so please ask me about it. Basically, bottom line is this technology is very powerful at modeling demographically grounded, quite predictable behavior. At the same time, the question of how do we model user behavior over time with language models is wide open. No one knows how to do this, right? So it's an interesting intellectual challenge. Can it be done? Can we do it? How will we do it? People are working on it. We're also really interested in empathy. I keep showing this. I think it's really important. By some measures, human empathy is declining for various reasons. We can debate why. So we did some studying to see not whether robots can be empathetic. That's not hard. You just tell the robot what to do. You prompt your model to say, be empathetic, and it'll say things like, oh, I'm sorry you're feeling bad. So that's not hard. What's hard is to elicit the human to be empathetic. So and why would we want to do this? Well, it turns out when you're empathetic, it's good for you. So you actually feel better, and your health outcomes are better, and you actually live longer when you're empathetic. So be empathetic. And why? Why is that? Because we're fundamentally social creatures. We evolved to be social. Empathy is a selected trait. Okay, so we want robots to elicit empathy in humans because it's healthy. It's like a health intervention that you would enjoy. And so we looked at what does that, and first-person narratives are much more powerful than third-person narratives. People prefer stories about humans than about robots. So we still prefer our own species. That's interesting and expected. And furthermore, we can detect, from facial behaviors, we can actually detect a correlation between when people say they feel empathy and when they're actually feeling it. And this is important because you heard from Rod this morning that people get very angry at robots, and then you heard it from me as well. Robots are terrible. They're not really effective at almost anything. And so they're annoying. So how do we make them less annoying? So we did a study, again, in this context of empathy. A really cute Curie robot. I really wish that company had survived. Those are great robots. So we basically created multiple versions of personalities, personas, if you will, for this robot. And one was neutral, and it would fail, and it would say, red text there. I've entered in physical contact with a wall, and functionality is failing. Or it was funny. I usually see quite well, but the darkness has taken me. We thought that was funny. And then the sad, I'm afraid I'll have to come apart to get fixed, and so on. And it was really interesting to wonder, what would people like best? Which of these robots would get the most help if it keeps failing? And a continually failing robot is really annoying. So, my personal guess was that the funny robot, or the kind of baseline robot, would get the most help. Actually, the funny robot. I thought, this thing is annoying. Maybe if it's funny, it would be best. The opposite proved to be true. People really love the sappy, useless robot. That one got the most help for the longest time. So this is interesting because the empathy was really evoked by this cute robot with sappy talking. But before you get too excited about humanity being so kind, one, people really hated the funny robot, which I don't know what that tells you. It wasn't even a mime, although it's kind of black and white. But it's contextual. This was a study, and people were not doing anything that's truly high stakes. And I think that's one of the major weaknesses of a vast majority of HRI work and the vast majority of work in robot development is we're not really testing it in really high stakes environments. So this is why, the Pepper robot, historically, it's super fun to play with in the lab, but then when it used to be put in phone stores, it would get kicked and abused because it was no good at actually selling phones, which is why you put a robot in a phone store. So this contextual stuff is really important. We are now actually putting robots in support groups. So we did this before the pandemic, and the pandemic hit, then we moved it over to virtual groups. So we have a robot in a virtual support group because there's just a lot of need for people to talk together and support each other, but you want to make sure that these groups are moderated, so no one is toxic, no one is overly negative. And these are cancer survivors, anxiety, depression, folks with real needs for support. And here's an interesting thing. Both in the robot conditions, so we told people that basically the robots were autonomous versus not. And what happens is the robot mediating the group reduced negative feelings and affect across the board, and these are clinical tests that we administered. But anxiety was not reduced by the robot that people knew was remote controlled. So this is really interesting because you would think, well, I don't really trust a robot that's working autonomously, but I like that there's a human behind it. But in fact, we found the opposite to be true, that people actually preferred the robot that was autonomous, and it reduced their anxiety more. Why is that? Well, there are a lot of interesting reasons why. People feel uncomfortable around people, they feel guilty, they feel like, oh, I shouldn't be complaining, etc. So it was a really interesting thing that actually behind the scenes, both robots, because they were using language models, both robots were actually ultimately Wizard-Ozzed because we did not trust the language models in a human anxiety and depression group to be fully safe. And I think that's a good choice. But it was very interesting that the humans preferred the robot being autonomous in this context. So again, things you find and discover. I'm gonna pull this together now, I promise. This is now we're getting into the latest stuff. Okay, so I made this claim, I'm gonna make it again, that the future of all of this stuff that we're doing with AI is personalized and adaptive. Now the personalized part, maybe people in this room think that that's a given, but it is not necessarily what industry is really focusing on. Right now, people would love, language models and foundation models to be able to give you what you need, but whoever you are. And not you specifically, but you generically. And my argument is that will not work. That will not work in most realms. People do not want transactional interactions. We really don't. We want agentic, personalized, adaptive stuff. And in fact, most things that we individually have challenges with require us to have a lot of grit and stamina and patience to keep doing it and to keep training and keep practicing. Think of any realm in life where you find a challenge, whatever it is. Tell me if it doesn't fit that. It's something you need to do, usually some behavior change, and you have to choose to do it, and you have to keep choosing to do it because you're going to keep failing. And that's where a lot of this support can come in. And I think this is an area where it becomes really interesting to talk about large models versus small models. We talked about this earlier today. There's a comment made by Chelsea about, she's worked with data that are only 15 minutes of interaction. We do that exactly as well from some really difficult domains. It's a very little data, but those data are like gold because the generalized models just have nothing at all from these populations, like kids with autism. And how do you learn from small amounts of data? How do you have the model using a large, like your agent using a large model for talking, right? So there's the talking and then there's the reasoning. And maybe it's using the large model to be a marvelous, interactive, generative, empathetic talker. But to be really personalized, it needs to know about you specifically and to keep track of you. And that gets into older style AI, right? User modeling, possibly RL. So now we're looking at very hybrid methods because you need all of this, right? You need the smaller models, but then you need the big models. Then you need RL, you need adaptation. You can't just fine tune all the time, at least not today. So this interplay is really interesting, unexplored. Why do we care? Because sometimes, and maybe a lot of the time, we want to deal with really hard problems. So the really hard problem that my lab has chosen to work on for over 20 years is autism. First of all, we know this is a really major challenge for our society. The numbers are now 1 in 39 children. It's more than quadrupled in the last 20 years. And individuals on the autism spectrum manifest just a constellation of symptoms and symptom severities. And most importantly, they're high variance, not just as a community, but within user, right? So over time, an individual, like a child with autism, will behave very differently session to session. So it is the hardest machine learning problem. I'm just gonna argue it's the hardest problem. There's no data. You can't have the internet's worth of data on autism. Nope. And in fact, I'll argue you won't. You never will. And so now what? And that's where we get into this really interesting space of, how do we work with small amounts of data? How do we train from each little tiny session? And so we've done that. I'm not going to play this video again. It's on the web. I love it.
Meet Adrian.
But I'll stop. But really, we and our colleagues at Yale, Brian Scazzolati's lab, we deploy these robots in homes of families with kids with autism for over a month at a time and got treasure troves of data, even if it's really small data, if you think about it. And I just want to take all my hats off to the students who did this, the villages of students who made this happen. It wasn't a company. No company wanted to do this because I don't know what they're working on. They don't want to work on this. It's $1 trillion, by the way, $1 trillion challenge economically, autism. So how do you deal with these really hard problems? And we looked at things like just understanding if a child with autism is engaged in an interaction. So everybody wants engagement, everybody wants eyeballs, but some of it is more typical than others. And with kids with autism, it's extremely atypical. Like I could be looking like this and I'm engaged, and how would you know? It looks like I'm not at all, like go away. But actually I am, right? Because that's my kind of engagement. And so understanding these personalized models, using multimodal data, which we're just talking about it. We have foundation models, but pretty much that's kind of video and audio. True multimodality is going to include, Rod talked about it. It's going to have forces. It's going to have tactile. It's going to have heart rate variability. It's going to have truly heterogeneous data, not just multimodal, heterogeneous. That's where we need to be going. How do you scale up models with all of that? Well, that's partly the robotics question. Things like personalization, right? You have to personalize a lot of things. You're not optimizing any one thing. So even just for teaching these kids skills that were mathematical as well as social, we had to optimize and continually optimize, so continually change and adapt the level of challenge as well as the reward we were giving. You can't just do one or the other, because there's valleys, there's thrust, and the kids will do well and then they won't anymore because either the material is over their head or the reward has gotten tiresome, because we're all reward-seeking mechanisms, but if you're getting consistent reward or punishment, it stops working. So there are many things you have to optimize, and our relatively simple models, sometimes of RL, also not good enough. How do we learn from each session, which is small data, and then add it and learn continually? So you have test time adaptation from all of the stuff that's come in, which, by the way, may be inconsistent over time. These are all current challenges for large models. There is no great answer. Just a couple of other compelling domains. Again, my great gratitude to the folks who did this work. Our collaborator, Amico Spitale, did a study during COVID in Italy using these robots to see if we can help kids with speech impediments and speech difficulties get speech therapy when speech therapists were not available in person. And the thing that was super interesting was the robots were really effective. So this was dialogue trees before LLMs, like right before. Super effective. The therapists were all really impressed. They said, this is great, it works great, we don't want it. We don't want it, would not recommend. So there's this really human social pushback. It works, it's great, I don't want it. And we see this a lot everywhere. And so we're doing this now, where now in the era of large models, there's beautiful stuff you can do with speech, with existing models. And we need small models and large models, because for all the giant models that are available out there, they're actually terrible at understanding speech that is atypical due to some kind of a speech challenge or speech atypicality. So again, we're not there. Will we get there, or is it even the right thing? Isn't it better to have a small model for just this? How does it interplay with the big one? So, some things to think about. We do physical stuff, lest you forgot that these are actual robots. We have done rehab work, and this is in many ways even harder. So we've done work with kids with cerebral palsy, motivating them to use an orthotic. And we were sort of having a robot learn how to motivate a kid to see what motivational strategies worked, while the kid at the same time is trying to figure out the robot and trying to trick the robot. So they're both motivated, but they're motivated with things that are sometimes in conflict, which is always a lot of fun. Also some stroke rehab work, again, from Nathan. And now I get into the stuff that I'm really excited about. Okay, so robots are not ubiquitous. We would love to have them be ubiquitous, so we've started to work with these really small, cheap 3D printed robots. I'll tell you a bit more about it, but let me tell you what we're doing. So I work with college students. I'm at a university, and so I let them basically tell me what they're passionate about. And one of the things they're passionate about is supporting attention and studying and ADHD. And so we developed a robot system that goes in the dorms, and it just sits there. What it's doing is this really fundamental socially embodied phenomenon called body doubling. So it's known in ADHD that if there's another human in the same room with you, not doing anything with you, just physically co-present, you can focus and concentrate more. What do you think that's about? Embodied social behavior. So we wanted to say, well, okay, you can't always have someone in the room with you. How about if we have a robot? Would it work? And it turns out it does work, but there's this wide open question about what should the robot do? Should it be drawing your attention? Should it not be drawing the attention? It can't just be turned off, because then it stops being an agent and it fails at its body doubling task. What's enough for agency? What's too much? Well, turns out it's personal. So there's no one size fits all. So we're doing more studies on that. And how do we scale this up? So robots are too rare, they're too costly, I can't believe this. I've been saying this since I was in grad school. I've been saying I want to go to a robot store, and I want to just go like, at your favorite store, Trader Joe's for me, and I want to be like, I want that one, and that one I'll take 2 of these. Still doesn't exist, and it's not even any closer to where it was when I started decades ago. So why is that? We want them to be affordable for everybody, but we also need them to be robust. We need them to be cheap so that we can do studies at scale. I'll tell you, we're doing a randomized controlled trial for NIH right now. I need to deploy to hundreds of people. How are we going to do that? So one of the things we're doing is, we had to develop our own. You're always developing your own. So now we have this really cheap, completely public domain test bed. It's under $300. You can put different skins on it. It can have lights. It can have tactile. Super fun. There you go. Don't tell me you can't get a robot. You can get a robot. So I want to wrap it up. We've got agents. They need to be embodied, but maybe you don't believe that, because wouldn't it be nice if they were just intelligent agents using these amazing foundation models? So we wanted to do the thing that we wanted to challenge the bazillions of people who say anxiety will be solved with language model-driven apps. Right? Who hasn't heard this? Everyone's heard it. Anxiety is a massive societal problem we have across the board. I won't talk about why, but it's a massive societal problem. And so, let's democratize the solution. Let's just talk to a chatbot. It'll be great. You'll talk to a chatbot and your anxiety will just go away. So we first wanted to see, can you actually, how well does that work? And how do therapists get evaluated? One of the ways that they get evaluated is this notion of entrainment, which is kind of the alignment between the therapist and the patient, or it doesn't have to be a patient, let's just say a customer. So how the client and therapist align is a really good predictor of whether the client will start to feel better. And it doesn't matter even what kind of therapy you're doing. It could be CBT, it could be DBT, it could be Jungian. The alignment is really important. This should be no surprise to anyone. So we first validated some automated measures of alignment, which I could talk about, but you'll be bored, NCLID and LSN and all this stuff. Anyway, they're measures. We validated them. They were valid measures. Then we tested this with LLMs. And guess what? Terrible alignment. People will engage in CBT. We tested CBT, not any other therapy, cognitive behavioral therapy. People will align. They will use, they'll use the therapist. But it doesn't actually, the alignment is terrible, and it doesn't actually reduce their psychiatric distress. So you have the novelty effect, you use it, but it's not actually helping you. So what's missing? Of course, embodiment is missing. So we did a study, initially just a pilot study, where we deployed the robots in the dorms with students who were not diagnosed as having depression, but did have anxiety. And we left it out for multiple weeks, 2 weeks, and then a pre-post week. And here's the key thing. Students think that robots are fun. We deployed robots, we deployed chatbots. Both were driven by LLMs, identical thing, absolutely identical input. So the only thing that's different is the delivery mechanism, the interface, which is either this cute little robot that doesn't do a whole lot, but it is physically embodied, versus your laptop, which you're used to. And then we did also a baseline with the notebook method, which is what you do actually in clinical CBT. Everyone hates that. And we found that first I thought, well, everybody will love the robots and they will do more stuff with the robot, which will probably make them feel better. Turns out, no, in terms of adherence, actually we didn't see significant differences in adherence. Now this is a study, so probably people felt that they should sort of adhere anyway because, it's a study. What we did find is that there was a significant difference in the reduction of psychiatric distress as measured by actual, DSM questionnaires for psychiatric distress. The chatbot did not reduce psychiatric distress in students, but the robot did. So this, I feel, is huge, and NIH gratefully agrees as well, so they gave us money to scale this really up and test it. Because we found that that interface, that embodied robot, just sitting there with the student and talking to them, reduces the student's psychiatric distress in a way that the LLM cannot, even though they're saying the same thing. But the interface is what matters. And what more proof do you need that we are social creatures and we're embodied, and it goes all the way down. And so on that note, I'm gonna end, finally, yes. So human-machine interaction has tremendous potential. It really, when it taps into who we are as social embodied creatures, then it can make us better, both in terms of how we feel and how we are to others. It has tremendous potential, but it has to be something that we actually care about studying, and then we study it with real users, real patients, real learners, real people in the real world with real functional tests. And we do it in a way that is not meant to replace, but rather to enhance and augment. And on that note, I just want to say thank you to my students. There they are, some of them, not all of them. And thank you to you.